Alright guys, welcome to our last part of this unit, Unit 5-6, where we've talked about slope, writing equations, and graphing equations, and various things, looking at real life instances where we had to look at what finding slope as far as the equations go, and determining cost of different things like in a cab, and finding out how much miles a person drove to deliver flowers. So you looked at a lot of things in this unit. Big unit. You guys have done a great job. So let's see if we can sum it up today with our uh, study guide answer key. Okay. Again, I've already posted the answer key to the Unit 5-6 resources. Uh, the actual answer key handwritten, but this little video, some of you said you wanted to see the video. So let's jump into it right quick. Alright, so the first problem we're looking at, it wants us to find the slope of the line. Well, I'm assuming on this one, we wanted to find the actual slope. But if I'm wanting to write the direction of the line, remember we're going to read this graph, reading it from left to right. Well, if I draw up here, remember we draw slope dude up top, he should be going downhill from left to right. So I know that this slope is a negative slope. Okay. Now let's find out the actual number for the slope. Well, if I look right here, I can put a dot here, and if I continue up my line, I see I can put one here because remember it meets a vertical line and a horizontal line. So I can put one here and right up under slope dude's foot, and right here and right here. Okay, so pick any 2 points, it doesn't matter, but remember we always try to do low dot to high dot. Well, remember I'm going up and I went left, so I went up 2, left 1. So remember slope is rise over run, and since we rose up 2 and we ran left 1, so that means it's going to be negative. So my slope for this line is m equals -2. Alright, so that was that one. Alright, so look at the next one. Now for this one, I've kind of just took a guess. I was reading the equation with the sentence that says which linear function is shown. So I don't know how the test is going to look. So I'm assuming it could be either given to you, say which one of these equations matches or which one of the tables matches. So we're going to do first right off the bat. We'll just kind of go up here real quick, do the same thing we just did. So remember we're looking for y equals mx plus b. We're looking for slope-intercept form where I need to find the slope and the y-intercept. Okay, well we know the y-intercept right now is +2. What I need to know is now what is the slope. Well, if I go up here, I can't put a dot. Here I can put a dot. No dot, put a dot. Remember the dots have to meet a vertical and a horizontal and my line. Going the other way, I can put a dot here and put a dot here. Well, I'm just going to go back to my point again. Doesn't matter which 2 dots I use. I'm going to use this dot. I went up 1 and I went left 2. So I went up 1, I went left 2. So that means this, my slope is negative. So if I look down here, -1/2 x plus 2 is this one. All right. Now, if she gives us tables, if the test gives us tables, then we can say, okay, let's figure out these points. Well, let's clear all this off. So if I find my points, let's just find out which one of these tables is contained in the graph. So if I start at -4, -4, +4. So go left 4, up 4, we can put a dot. -2, +3, we can put a dot. 0, 2, we can put a dot. And 4, 0, we can put a dot. So if you'll notice, all of our dots are in this table. There's our answer. Okay, so I don't know how it's going to be asked, but now you can look at both ways and you can see how they go. Okay, all right. So let's go back over here to the next one. Which statement is true concerning the slope of the line below? Well, first off, we know it's a positive slope line. So by process of elimination, if I look at my answer choices, I could get rid of one of these, which right now I know for a fact I could get rid of this one because it says my slope is going downhill. Well, you know, we like to give a little dots. I'm gonna label these little dots. I'm gonna label them A. I'm gonna label this one B. I'm gonna label this one C. So we want to look at right here. So let's find out which one of these it can be or which one it cannot be. So if I go from A to B, let's find the slope of the hypotenuse, or the slope of this line between A and B. Well, my rise is 2, my run is 3. So I have a rise of 2, run of 3, and since I went to the right, my slope is positive. So it's +2/3. Well, if I went B to C, okay, so the same concept, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 4 over 6, and if I notice, I can reduce that by dividing both of them by 2, gives me 2 over 3. So both of my slopes are 2 over 3, which kind of eliminates this one. Okay, so we're down to these two. The slope is equivalent to the simplified ratio of the horizontal to the vertical. Well, if we think about horizontal, remember horizontal lines run left to right, and vertical lines run up and down. So what it's telling us right here, and if we do that, so what it's looking for, we have this over this. Well, if you remember, this is run and this is rise, which that is not the definition for slope, so it can't be run over rise, so it can't be that one. So the simplified ratio of rise to run, that's the one we're looking for right there, the simplified ratio. When we reduce this one, we have a simplified ratio that both of them are the same, which makes these two triangles similar. Okay, so remember that we're looking for here, this is the key. This is horizontal over vertical, which is run to rise. But this one is rise to run, which would be vertical over horizontal. That is rise over run. Okay, so think about it that way. But we're looking at that, we're reducing that fraction to 2 over 3. All right, here's the next one. Write an equation that represents the graph below. Okay, I'm assuming there are going to be some actual choices for you, but right now, right off the bat, before I do anything, I notice that this graph is negative. It means it's going downhill, reading left to right. Well, we're going to write that equation, so again, we're looking for y equals mx plus b. So let's fill in what we know. Well, here's the b. This is the y-intercept. This is where it crosses the y-axis, and it's crossing at plus 1. So now we have this. Now all we need now is our slope. No dot can go here. Well, it can be up here, dot here, but remember we want to try to find one that meets at a corner. Nothing wrong with putting a dot here. It's just that you have to worry about working about a decimal, which you guys have calculators, so we can do decimals. Okay, but we want to try to avoid them if we can. All right, so now let's pick a dot. It doesn't matter which two, but I'm going to go back up here to the y-intercept. I'm going to go up, and I'm going to go over. So 2 over 1. So my rise is my 2, my run is 1, and I went to the left. Okay, so that's negative, and I'm negative here. Now, nothing wrong with this equation, but remember, please, if you remember on a test, you're not going to see it over 1 because it's a whole number. So this would be your final answer. Y equals negative 2x plus 1. Okay. Number 5, write the equation or find the equation of the line. Same concept again. I'm assuming she's going to give, or we're going to have some answer choices over here. But remember, we can do it again. First off, this line again, I notice that is going negative, going downhill from left to right. And remember, we want to write it as y equals mx plus b. All right, well, my b is the y-intercept. That's where it crosses the y-axis. So it's negative 1. Then if I can put my dots, again, I could put a dot here, but we want to make it a little easier on us. We're going to put it right here. We're going to put it here, 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 and here. And again, it doesn't matter which two dots I use, but I want to try to use some that are close together so I don't have to reduce. But I could use this dot to this dot. It doesn't matter, but I'm just going to stay with my y-intercept, which is negative 1. So I'm going to go up to left 1. Oops, let's back that off. Okay. Up to left 1. Okay, so we went y equals, we went up 2, and we went left 1, so that makes it negative. Okay, again, nothing wrong with this, but please remember you're going to see it written like this, negative 2x minus 1. So the only difference between that graph and the one before was the line was just shifted down from here to here. Okay, all right, number 6. We're comparing a table, so this right here, remember, should be apples, not tickets. So we're comparing apples to oranges, okay? Well, if I'm looking here, what it wants to know, what is the starting amount for each one of these functions? Well, remember, if I don't see, here's my magic word, so let's talk about this. So what's behind it, I'm sorry, there's my magic word. So what I'm talking about here, what I'm looking at is for what would actually be here is the number of oranges. I'm paying 50 cents for each orange. Well, If I have not purchased any oranges, then I have paid no money, right? Okay, so remember this equation really is y equals 0.50x. The total cost is equal to 50 cents times the number of oranges, right? Well, if I don't buy any oranges, 0.50 times 0 is 0. Well, here in the table, if I buy no apples, I've spent no money. So the total cost, this total starting amount for each one of these is 0. So we also gave out a new word. Remember we talked about this word. The initial value of each one of these is going to be 0. Now, it wants to know which function has a greater rate of change. All it's want to ask you is which one has the bigger slope. So we're looking for the bigger number. Well, here, the slope here, every time I buy an orange, it goes up 50 cents. Well, here, it looks like it's 65, but I want to make sure that my change is constant. And if I subtract 130 minus 65, that is 65. And if I subtract 195 minus 65, that's still 65 cents, right? Okay, so the slope here for the apples is 0.65. Well, if I compare these two, 65 cents is bigger than 50 cents, so the apples will have the greater slope. Okay, that means they would cost more. And if I buy an apple or buy an orange, my bill would go up faster by buying more apples than I would oranges. Okay, all right, good job so far. All right, let's go to number 7. What's the rate of change? Well, remember, rate of change is nothing but slope. And we determine slope by the change in the y values over the change in the x values, which is the change in y over the change in x, which is rise over run. Well, remember, your x values are your run because that's left and right, and your y values are your rise. Your y values are your rise because it's up and down. So if I go from here to here, each one of these values are adding 3. I'm going up by 3. Each one of my x values are increasing by 1. So my rise is 3, my run is 1. And if I reduce that fraction, it's 3. So the slope or the rate of this change for this table is 3. Let me fix that. The rate of this change for this table is 3. Okay? All right. Is the slope positive, negative, undefined, or 0? Well, no slope is not really no slope. It is 0 slope. Okay? Let's fix that. 0 slope. So remember, if we talk about Slope Dude's journey, remember he's skiing along. Well, remember, if he starts up the hill, fix this again. If he starts up the hill, then that's a positive slope. Coming down the hill is negative slope. On the flat part, that's 0. And then the up and down part is the undefined. Okay, remember that's the word we talked about. That's kind of a no-no word in math. Okay, so that's the vertical line. So if I look here, if I'm following this graph, remember we read a graph from, y'all, I'm sorry, this pen's messing up again. Y'all know how it goes. Okay, we read a graph from left to right. Read our graphs from left to right. So if I'm reading this graph, if I draw Slope Dude, here he is. He's going this way, which if I match it up, he's going uphill, so the slope of this line is positive. Okay? Okay, this is the one we talked about in class. This one is kind of confusing because we want to start at the top of the mountain. Well, according to this one, it's the distance from where she's standing now. Well, the distance she's standing now is at 0. So she's standing right here. So we want to draw some slopes to kind of match this up. Well, if I look up here, I see here's one slope. She stayed at the top of the mountain 2 minutes before heading down the slope. She went faster and faster, so that's telling me 2 slopes. Then she slowed to a stop. That slowed part to me would tell me there's a change in her slope. There's 3. Then she stopped. That's 4. And then she walked. That would be 5. So I'm going to try to draw 5 slopes here. Well, here we're sitting at 0 distance at 0 minutes. So from somewhere right in here, we're just going to kind of freehand this. For about 2 minutes, she waited. So time's going by, but distance is not. So it's a flat line. Then, so that's 1. So then she went really fast. So she's going for about 5 minutes. She went really, really fast. Now, even though it says she went down the slope, we're looking at the speed. So the speed is really, really fast. It could be faster than that, but we're just kind of eyeballing it. So for around 5 minutes would give me a total of 7. And then somewhere around here she's slowed to a stop. So I'm going to say something like this. So we see the change in the slope. So her speed slowed a little bit, so it's not quite as steep. So that would be number 3. So here's number 1. Here's number 2. Here's number 3. Now remember, when we have a stop, what we're looking for is time is going to continue, but the distance from the start is not going to continue at all. It's going to stay flat. So that would be number 4. And I don't really know how long she stopped right here. We'll just say 1 minute. So there's 8 minutes. And then for the last 10 minutes, she walked to her car. So I need that slope to be somewhere between these two because she's skiing really fast and slowing down. So something along that line. So it's a little bit steeper. I mean, a little bit, not close. Let's back that off. Let's make it not quite as steep. So it's not quite as steep as when she's slowing. It's really not as steep as when she's going fast. So somewhere around 18 minutes, she's back at her car. So the whole key is to finding out where she is from her distance. Well, here she never came close to the bottom, so she's going away from where she started. So kind of look at that, and always remember to read your axes, and your axes will help you out a little bit. Okay. All right, number 10. All right, Team Aces, Team Kings. We're going to make a difference. We're going to describe a difference. Multiple ways to do this. So let's just talk about right off the bat. Team Aces. Well, if I'm looking at this chart, I know X and Y. This is my input. This is my output. I want to find the rate of change, which is the slope of the line, right? So here we go. Let's find the slope. So everything I'm going here, every time I move up, I'm going up 10 on my Y side, and then on my X side, I'm going up by 1. So the slope here is up 10 over 1, which is 10. So Team Aces is traveling 10 miles per hour, 10 miles in 1 hour. Okay, let's see what Team Kings is doing. Well, here's Team Kings, and if I go up, I can put a dot here. So if I look at these guys, they're going up 2 over 1. So they're traveling 2 miles for every 1 hour, which gives me a slope of a positive 2. Well, now, if I'm making a comparison between these two guys, or these two groups, well, if I look at 10 and I look at 2, one thing I could write was that Team Aces is traveling faster than Team Kings. Okay? That's a good comparison because 10 is bigger than 2. Well, another one I could look at, if I'm looking at the word difference, I'm thinking subtraction. So I might could say Team Aces is traveling 10 miles per hour. Team Kings is traveling 2 miles per hour. So that's a difference of 8 miles per hour. So Team Aces is traveling 8 miles per hour faster than Team Kings. Okay? Then if we make that ratio, if we compare the two, 10 over 2, if I compare the two slopes, I can actually come up with the number of 5. What I can say now, according to this 5 tells me that Team Aces is traveling 5 times faster than Team Kings. So it all depends on what the problem, the answer choices are. But there's multiple ways to compare these two. So we compared them by the actual, just what's going on, which one's bigger, the difference, which is subtraction, and then also the actual times greater. How many times faster are they going? So multiple ways to do that. Okay. So first off, you got to find your slope. All right. Number 10. Which one of these is a greater rate of change? So which one is the biggest slope? Well, if I look right here, the slope, the number in front of X is 4. So the slope is 4. Well, if I go here, each one of these are in by 1. Increasing by 1, so 1 over 1 gives me a slope of 1. Well, if I look right here, this end is actually going up 1 over 2, so I have a slope of 1/2. Okay, let me fix that. A slope of 1/2. Now we got to figure this slope out. Well, if I look right here, remember the word is means equal. So a number y is 2 more, means I'm going to add 2 to something. Well, that something happens to be the letter x. Okay, so what I'm missing now is my slope, which is going to be 1 over 1, which is 1. So the slope for this is 1. So which one has a bigger slope? Which one's a bigger number? 1, 1/2, 1, or 4? Well, 4 has the bigger slope. Okay, so the bigger the number, the steeper the slope. Which one describes this line of the graph? Okay, well, if you look again, we talked about this just a few minutes ago. Positive, negative, 0, or undefined, right? Well, excuse me. This line is looking like this line. It's going up and, excuse me again. This line is going up and down, right? Okay, so if it's going up and down, we have undefined. All right. Number 12, which one of these represents a linear function? Well, remember linear functions, if you're looking at this, you're looking for something that has a constant change of both the x and y variables. Of x and, not and, excuse me, the x and the y variables. Okay, so you're looking for that constant change. Well, before I even look at this one, I don't even need to worry about this one because I know this one is not even a function at all, because a function, remember, none of the x values can repeat. But so this one is definitely not going to be an answer. But let's look over here on the y side, because we do have a constant change right here of 0. But if I look over here, this goes up by 3. This one goes up by 2. Let me fix this, guys, in case y'all are trying to see this again. Just give me just a second. All right. So from 3 to 6, if I do 6 minus 3, that is 3. If I go from 6 to 8, I've added 2. Well, these two numbers are different, so it's not a constant change. I have a constant change here, but not here. Well, let's go over here and look real quick. From 0 to 6, I added 6. 6 to 8, I added 2. 8 to 10, I added 2. Okay, so that's not looking too good. So that's not a constant change. 2 to negative 1 is down 3. But negative 1 to 4, I'm going to add 5. So I don't have that constant change here. So that's not it. Well, this is an inequality, which we don't even talk about inequalities. But this one is not going to be a vertical. This is actually going to be some shading. We're going to talk about it later. Here's your answer right here. That's a straight line. So a linear function means straight line. Okay? So just look at your changes on your tables. If they're not constant, it's not going to be a straight line. Okay? Fill in the table real quick. Let's do this real quick, then we'll fill in the table. Well, if I want to do this, first off, I can do this without any kind of table. I know that's my y-intercept. There's my rise. There's my run, right? So we can put a dot right here because there's my y-intercept. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3, right 1. 1, 2, 3, right 1. When we run out, we go the other way. 1, 2, 3, left 1. 1, 2, 3, left 1. And draw your line. So we don't even need that table, and I know that's not on the line, but let me fix that. That's not on the line. I can draw it a little bit closer. I can draw it a little bit closer. There we go. All right. So now I can actually fill in my table from my points. Well, here's an easy one right here. 0, negative 2, which is this point. Negative 1, negative 5. Negative 1. Negative 1. I don't know why this thing's doing this. Give me just a minute, guys. Negative 1. Okay. And negative 5, which is this point. We could say 1, 1. And we could say, what is this? 3, 7. So any one of those points you want to pick to put in there. Also, please remember, we got these points. We actually could take these. You could take this x, put it in right here. So 3 times 0 is 0 minus 2. So there's my output right there. Input, output. Okay? All right, we're going to speed up just a bit. 15. Bob has $12 and he makes $5 per hour washing cars. Use this equation, y equals 5x plus 12. What I want to know is, what does the slope represent? Well, to figure that out, I need to find the slope. Well, we're looking for that magic word. There's the magic word. Remember, the word behind slope, behind per, usually is going to be my x variable. And that number that's really, really close to it and very associated with the number per, or the letter per, excuse me, the word per, and hour, right here is my slope. So in this case, my slope is 5. Well, what that asks me is, what does the slope represent? Well, what the slope represents in this equation right here is 5. That means $5 per hour washing his car. So what it is, that's the total car, I'm sorry, the amount that he makes washing cars. The amount per hour, excuse me, he makes washing cars. Okay, so there it is right there. The amount he already has, that is your initial value, so that's that plus 12. And the total is your output, which that's what we get from the number of cars he actually, the number of hours he actually works washing the cars. But all it wanted to know is, what does the slope represent? Okay. All right, 16, graphing these slopes. Remember, positive slopes, we're going to be going up from left, and I'm going to abbreviate, to right. I don't care how you draw it, where you draw it. We're going to go up from left to right. Okay. This one is down. I'm sorry. I jumped to the wrong side. This one over here, excuse me, is down because we have a negative slope. Down from left to right. So it doesn't matter how you read it. All right. Now the zero slope. This one is a horizontal line. We talked about it being flat. Remember, zero and horizontal both have the letters Z into them. Okay. They also, you can read them left to right or right to left, doesn't matter, as long as you understand that it is a flat line. Zero slope is not going up, not going down, not falling off the mountain. Okay, so he's going very flat. There's your zero slope. Now undefined, when we talked about this in class, we can use these two words right here, these letters right here, right? Undefined means up and, excuse me y'all, let me see if I can fix this. Up and down. So my line here for an undefined line would go up and down. So this has to be a vertical line somewhere. So this one's horizontal. This one is vertical. So it's going to go up and down. Okay, up and down. So remember about that. Well, somebody come up with that in class the other day. Draw this graph real quick. Well, if I graph this one right now, I know there's my y-intercept, there's my slope. And it should be, since I'm looking here, this should be a positive line. Okay, so we're going to start at -2, and we're going to go up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. So it's just like a dance step, right? Once you learn it, up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3. When we run out of room, we go the other way. Down 1, 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3, and you should finish with a straight line. And when I finish, I'm going to check which way is slope dude going. Well, he's going uphill, which left to right, that's positive. Okay, so always go back and check and make sure which way he's going. Okay. 18, which one of these matches the graph? Let me pull this over just a little bit. Let me pull this over some. Here, all you're doing is which one of these has those dots. Well, if I look right here, I'm not even going to fool with that first dot because the first one is the same in every one. So I'm going to look at that second one. So -1, 0. So if I go to -1, 0 and put a dot right there, that's not touching the line. Okay, so it can't be that one. Well, they have the same number here. It can't be that one. So it's got to be this one. So let's just make sure. I want to make sure because I like to be safe before I put in my answer on my test. So if I graph this point that says go left 2, up 3, well, there's a dot. Go left 1, up 1, there's a dot. 0, down 1, there's a dot. And +1, -3, well, there's a dot. Well, all of those are on the graph. So just eliminate the ones you can use and the ones you can't use. Okay. Draw the function y equals x. All right. Well, we're missing a couple things as far as the visual. Okay. Some of you are like me. You're kind of visual, which is not helping you with this pen that I'm using. Okay. Because y is equal to mx plus b. Well, up here I don't see all of that. So that means I've got to add a little something to it. So what I have is, I'm just going to rewrite that equation. Now what I'm missing is, if I don't have a y-intercept, that means 0. If I have a x, that means I've got to have a slope, and it's going to be a fraction of 1 over 1 since it's positive. So that says start right here at 0, go up 1 over 1, up 1 over 1. Again, it's just like that dance step we talked about. As you go up, As you go up one, you go over one. Now when you run out, come down one the other way. Let's go the other way. All right, and then draw your line. Okay, there it is. The graph y equals mx goes through the origin. Okay, y equals x. All right, next one. Which one of these is the graph of y equals x? Well, we just did it. It's the positive slope line that goes through the origin. Okay, now what's the difference between that one and this one? It goes through the origin, but it's going downhill, so this equation would be y equals negative x, right? Okay, all right, so let's see what we got next one. 21. Al drives a cab. He charges $4 to pick you up. There's your initial value. That's what he's going to charge just to come to your house, right? Initial value is here. And then $2 for each mile. Well, there's my magic word. Okay, so all I'm looking for now is right here. There's my x variable. There's my slope. Okay, so in this case, then the x variable means the number of miles. Just hold on a second, guys. The x variable means the number of miles. Let me erase this. The x variable, okay, is the number of miles. That's all you're looking for right here. That's all it asks you to do, is find the number of miles driven, okay? Well, let's kind of add a little bit to this real quick. What if it gave me this equation and said, what would it cost using this equation? What would it cost if Al came to pick you up and drove you, let's just say, 20 miles? What would be the cost of the bill? When you get out, what would you have to pay Al? Well, if you look, remember again, miles is your x variable. So all you're going to do is take this number, plug it in right there. So 20 is going in for x. So 2 times 20 plus 4 would be 44. So when you got out of the cab, you would owe Al $44. Okay? All right, let's say, what if you get out and Al tells me, say, hey, you owe me, let's say you owe me $76. So Al says you owe me $76. How many miles did you ride for $76? Well, you take that same equation, and this time, since it gave you the amount of money, that one's going to go here. Okay, so we're going to plug it in for the cost per, the total cost for riding in the cab. So 76 is equal to 2x plus 4. Well, to solve for this problem, remember, all we're going to do is we're going to subtract the 4 from both sides. So we have 72 equals 2x. All right, and then the last step is to divide by that 2. And when you divide by 2, you should get, hopefully, we're going to get 72 divided by 2 is 36. So you should have ridden 36 miles in the taxi cab, okay? All right, 22, draw the graph y equals that. So y equals negative x plus 1. Well, it should be going downhill. Now, I have a ghost right here, so I'm going to put 1 over 1, but I'm going to start at positive 1. I'm going to go up 1, left 1, because it's a negative slope. I've got to go to the left when I run, okay? Go all the way up as far as you can go. I'm not going to go all the way down, but remember, I would come down and go the other way, all the way down, and draw your line. So it should be something like that. And when I finish, check with old slope dude, make sure he's going the right way, because it's supposed to be negative, and he's going the right way. All right, 23, which one of these? All right, remember, before we do this, let's kind of give some letters here so we can see which one is which. Let's give it a few letters. If I can get rid of this letter. Okay, that's a C. Now let's see what we got here for D, if I can find my pen. Okay, all right. So which one of these is increasing at the fastest rate? Well, what it's asking for, remember, which one has the steepest slope, or which one is the closest to vertical? Well, if I look at these ones, the one that's closest to vertical is right here. Remember, vertical is up and down. So this one would be B. Which one of these increase at the slowest rate? Well, no, it's not that one, so that's a little fast. These two are pretty close, but if you look, this one is a little bit closer to the horizontal one, right? So the closer to slower is horizontal, so we're going to say C. Which one of these have similar rates? Well, if you look, they're really close, are C and D. The only difference between these two is D has an initial value of something other than 0. This initial value is 0. Okay. All right, 24. I know we're going to run out of time in a minute, so let's keep going. This one says start at positive 2. And I'm missing my run, so I'm going to put a 1 under there. So we're going to go up 2, left 1. Can't go anymore, so we're going to go the other way. Down 2, right 1, down 2, right 1, down 2, right 1. And again, we're going to check with slope dude to make sure we're going the right way, because we should be going downhill, and according to this, I'm going downhill. Okay, so that's going to just check it, draw it and check it. Okay, the equation. Okay, I'm assuming you're going to have some equations to match on this one. So remember, mx plus b. All right, where does it cross the y-axis? That is the b. Well, it's crossing right here at plus 5. Okay, we're going to cross at plus 5. So we have y equals, now let's find out what the slope is. That looks like greater than or equal to, doesn't it? Sorry. Y equals, all right, so here I'm going to go from this dot to this dot. I went up 3 over 1, and since I ran to the right, 3 over 1 reduces to 3, so y equals 3x plus 5. Excuse me. Y equals 3x plus 5. All right, give me just a second. Let me fix this. Y equals 3x plus 5. So there's your equation for this line. Okay? And again, it's positive, so we should be going uphill. All right, last one. You guys have done a great job bearing with me. All right, please remember, we're going to do away with this. You know, we don't like to do the down and right. We like to go up and to the left, right? Okay, so we're going to redraw this real quick, just for a second, even though I didn't change colors, which I wanted to. Okay? All right, so the slope of this line, well, the first thing I notice about is going downhill from left to right, so that slope is going to be negative. Well, I want to know exactly what it is. Well, if I pick this point right here, and I pick this point right here, I can find the slope. So I went up 2, left 2. So up 2, left 2, and if I reduce that, it gives me negative 1. Okay, so there's my smaller triangle. So we know the slope of this one is negative 1. Well, if I look at this problem, and what I can look at is I see it says it wants to know about the smaller triangle and the larger triangle. It wants me to compare the two. Well, if I was to compare these two, if I look from here to here, then that rise is 3, and that run is 1, 2, 3, excuse me. Okay, so the smaller triangle is 3 over 3, and I went to the left, so that's going to reduce to negative 1. Okay, give me just a second. Let me fix this. Okay. Okay, so we're going to reduce that to negative 1. My pen's not wanting to cooperate with me today. Okay, give me just a second. Okay, well, if we reduce that to negative 1, what we notice is if this is negative 1, that's negative 1, then the smaller triangle and the larger triangle shown are similar triangles. That means they are similar because their slopes are the same. Okay, so the smaller triangle and the larger triangle shown are similar because their ratios are the same. So that would reduce to negative 1. That's negative 1, right? And then the simplified ratio of the rise and the run of each triangle is the same, which makes it, let's go back and fix this real quick. Okay, so these two triangles, the smaller triangle and the larger triangle, are the same, which makes them same slope, which makes them, this is what I'm looking for. This is the word I'm trying to use right here. These two triangles are similar. They're not congruent because, remember, congruent means they are exactly the same. Well, these have the same shape, but not the same size. Okay, so remember, congruent means same shape, same size, and same angle measurements. So the ratio of the rise to the run of each one of these, well, you did each one of them. The simplified ratio is negative 1, or they are the same. Okay, so again, I want to go back to this part real quick. The smaller triangle and the larger triangle shown are similar because they have the same shape, and the same uh, angle measurements. If you look, both of these should be right triangles, but they have different size, which what makes them similar. Okay. All right. Please look over this again, and I apologize again for the pen not acting like it's supposed to. But you have an answer key on the website on the other page over there on the resources. Now you have this video, and you can kind of go back and watch it. And please study hard, and look forward to seeing you tomorrow in class for the test. Thank you.